Hi everybody, it's Mrs. Dunn. So we're solving systems of equations again, but this time we're going to use a new method. We're going to use matrices to solve this system of equations. So let's get started. Let's start with this example from a previous screencast. We started with this example when we first started to learn about how to solve systems of equations. So we have x minus y equals 5 and 2x plus y equals 1. To solve these using matrices, what we're going to do is write this information in matrix form. So we take this information and we take x and y out of the problem altogether. We use this straight vertical line to represent our equal signs, and we just write down the coefficients. So we have the coefficient of x is 1, that's what's written here. The coefficient of y is -1, and the coefficient of 5, 2, 1, 1. And remember that line represents the equal sign. What we have here, this matrix, is called our augmented matrix. Now, just so that we understand what we're talking about, we have rows of this matrix. The rows are, indicated here. So the rows are the horizontal lines. And then we have the columns. And the columns are the vertical lines. So this matrix has 2 rows and 3 columns. So we say it is a 2 by 3 matrix. Okay, now what we're going to do is I'm going to teach you a couple things that you are allowed to do with matrices, and then we're going to use them to solve this system. So here are some row equivalent operations. We're allowed to take a matrix and interchange any 2 rows. We can multiply every entry in a row by the same non-zero constant, and we can add non-zero multiples of one row to another row. We also need to understand what row echelon form means. So to put an expression into row echelon form, we're going to make the leading term in that row, the first term in that row, a 1. So if a row does not consist entirely of zeros, then the first non-zero element in the row is going to be a 1. For any 2 successive non-zero rows, the leading 1 in the lower row is farther to the right than the leading 1 in the higher row. And all the rows consisting entirely of zeros are at the bottom. And then there's one property that must be satisfied for a matrix to be in what is called reduced row echelon form. And that's where each column that contains a leading 1 has zeros everywhere else. That seems really confusing. It's easier if we look at an example. So for example, let me go back here. So for example, here are 6 matrices. Which of these are in reduced row echelon form? Well, I started to circle one of them, and that is in reduced row echelon form. It's in reduced row echelon form because it has 1s on the diagonals and zeros everywhere else. So I have 1s on the diagonal here, but I don't have zeros everywhere. So this is not in reduced row echelon form. Also not in reduced row echelon form. I don't have 1s on the diagonal. Don't have 1s on the diagonal, not reduced row echelon form. So the only other one that's in reduced row echelon form is letter E. Okay. All right, so let me show you how this is done with this system that we started with. So first we have the augmented matrix, and then what we're going to do is some row operations. So remember, we want to end up with a 0 underneath this 1. We have 1s on the diagonal. What we don't have is a 0 here. So I'm going to multiply the top row by -2, add it to the second row, and that'll become my new row 2. And so I get 1, -1, 5, 0, 3, -9. -2 times 1 is -2 plus 2 is 0. -2 times -1 is 2. 2 plus 1 is 3. And -2 times 5 is -10 plus 1 is -9. Now, the next thing to do is get a 1 here. To get a 1 here, I'm going to multiply the second row by 1/3. And that's going to become my new row 2. So I get 1, -1, 5, 0, 1, -3. Now I need to get a 0 here. To get a 0 here, I'm simply going to add these two rows together, and that new row is going to become my new row 1. So when I do this operation and add those together, 0 plus 1 is 1, 1 plus -1 is 0, and -3 plus 5 is 2. So that's where this matrix came from. Well, that's it. Once I have this in reduced row echelon form, which I do, I have the answers, because this expression says x equals 2. This says y equals -3. And that's the solution, 2, -3. Okay, now let's do this with a larger system. And this is where it gets crazy. Follow along as best you can, and then I'm going to save your life with an easier way to do this in the next screencast. Okay, so here's our system. 2x minus y plus 4z equals -3, x minus 2y minus 10z equals -6, and 3x plus 4z equals 10. First thing I do is put that into an augmented matrix. And now I'm going to be working vertically. In the next step, what I have to do is get a 1 in that first spot. So I've got to change this 2 to a 1. To do that, I'm going to switch rows. So I switched row 1 and row 2. So row 1 becomes what was row 2. 1, -1, 2, -10, -6 moved up, and 2, -1, 4, -3 moved down. That's the easiest thing to do. Now what I have to do is get zeros underneath there. So to get zeros underneath that 1, I'm going to multiply the top row by 2 and add it to the second row, and multiply the top row by -3 and add it to the third row. I hope I said -2. I feel like I might have said +2. But I'm multiplying this top row by -2 and adding it to the second row. -2 plus 2 is 0. -2 times -2 is 4, plus -1 is 3. -2 times -10 is +20, plus 4 is 24. -2 times -6 is +12. 12 plus -3 is 9. Same thing, except we're multiplying by -3 to get the third row. In the next step, I need to get a 1 here. So to get a 1 here, I'm going to divide this whole row by 3, which is the same as multiplying by 1/3. So 3 divided by 3 is 1, 24 divided by 3 is 8, 9 divided by 3 is 3. Okay, so now what I need to do is I need to get zeros here and here. So first I get a 0 where the 6 is. So to get a 0 where the 6 is, I multiply the second row by -6 and add it to the third row. All right, getting complicated, right? Now I'm going to get a 1 where that -14 is. To get a 1 there, I'll divide that row by 14 or -14, same as multiplying by -1/14. Now this is what's called reduced row echelon. This is called row echelon form. We want reduced row echelon form. So that means we're going to have to get zeros here, here, and here. So you can follow these steps, and we end up in reduced row echelon form. And what this expression says is x is equal to 3, y is equal to 7, and z is equal to -1/2. And that's the solution. I know this was tough, but hang on, watch that next screencast, because I think you're going to find that one awesome. It's going to save you a lot of work and make this so much easier. So please tune in for the next screencast.